Hi, welcome back to TechGuru-RealTime channel. Today we are going to talk about the real hands-on demonstration on Kubernetes Gateway API. Stay tuned and watch until the last so that you can understand this entire demonstration. Let's jump in. So in part 10, we understood Kubernetes API gateway history and all those things. I'm just going to reiterate few samples here. Kubernetes Gateway API, it is offering a standardized way to manage network traffic going in and out of Kubernetes cluster. That is the first motivation. Kubernetes API Gateway version 1.0, the actual API beta version when we are doing the manifest configuration. So we can see that officially launched recently, that is on 31st October 2023 year. New logo was created for Kubernetes Gateway API. You can see that from part 10 or here as well in the next upcoming slide. Gateway API for Ingress. So they were replacing the earlier Ingress controller with Gateway controller to manage and maintain unified network approach whenever it is dealing with the applications. Okay, so we're supposed to have a standardized Kubernetes custom resource definitions. Whoever is the implementation partners, they're supposed to follow the CRD and then they're supposed to adapt according to their product development. And this must support with Kubernetes 1.24 plus. That is the so to have the demonstration, we must have these prerequisites. So standard channel, if you want all these details, please refer part 10. Standard channel, which is the one I'm going to use, that defines the custom resource definitions, which is essentially required to apply in the running Kubernetes engine. Okay. This release was primarily focused on ensuring that the existing beta APIs were fully defined when interacting with Gateway API. And now we need some product which implemented the gateway controller, which is defined by the standard channel. So there were different vendors who is supporting Ishito. This is completely open source, and APG, Mule Gateway, Nginx, Console, Glue Edge, and Console. There are different vendors who is supporting this. Please go through the list of implementation providers. So in this particular exercise, I'm using Ishito is a service mesh, and also it is implemented the gateway controller and it is open source. That's the reason I have selected this product. And Kubernetes engine, which is v1.24 plus. In my side, I'm using Minikube, which is 1.2.8. Here what we are going to do, we are creating a gateway, we are creating HTTP routing, we are creating an application service, we are creating a deployment, that is a pods, manifest, and hosting, and we are going to test it. So this is the new logo as per the Kubernetes. This is the new directions, the arrows, which is saying that you can dispatch a request to different gateways, and underneath the gateways you can route to your request to multiple Kubernetes engines. Okay, so you can refer part 10. So this gateway control class, which is Ishito used and implemented it, I'm going to use that service, and I'm going to define a gateway. So I can route my request to respective HTTP routes. This is the layer 4 and layer 7. You need to study those things as well. So this is the ideal architecture with respect to Kubernetes gateway, which they were telling. So cluster operator, it is a cluster resources where who can control of what. That is how a client can communicate with this domain, followed by the path definition store. Then all the requests go to store namespace, and they can put wait, and then they can dispatch the request. That is how it is. So this is my realistic deployment architecture, what I am going to do the demonstration. I can use either web browser or I can use a CURL for testing this. I'm going to create a namespace NSGW gateway, and the name of that gateway is Narayana XLB, external load balancer, which is going to run on port 80. That means running Kubernetes engine going to have one of the namespace, and then I'm creating another namespace called NS Hello App. This namespace I'm going to host three things. One is HTTP routing, and then service, and then pods. That is a deployment. The pods for easy testing purpose, version 1 and version 2 I'm representing, so that whenever we are testing, we can see that how the basically the request is being dispatched to the respective backend services. So this is the realistic. So here everything, the architecture which is running in my local is, so I have a Windows operating system, I have a Linux operating system, and underneath the Linux operating system there is something called Minikube, which is the host running, and there is a service which is exposing 5000 port. Okay, so we are going to test that. So these are also additional prerequisites: Docker public registry access and Kubernetes Minikube, and not only Java developers, any developers. So these are the reference links. Let's jump into the hands-on session. So we need to do three things. One is a gateway service, one is a routing service, one is the deployment of our pods. Let's first create namespace. Create ENS two namespaces, gateway, and we are going to create hello app. This is what we were represented in our architecture model. So two namespaces, we are ready with it. Now what we are going to do it, we are going to create a deployment based architecture. That is what we are going to do it now. So let's go ahead and see what I'm going to deploy. So this is a service which I'm hosting. This service is going to have 5000 port, and it is going to choose on some deployment. The deployment name is hello world. So here you can see that I'm defining the deployment labels v1 and v2. There are two types of applications which is using here, v1 and v2, tagging to the same service. Let's go ahead and deploy. Where I'm going to deploy, I need to deploy into hello app is the namespace service. I'm going to create deployment process there. Apply -f hello world. Now my applications has been deployed. Let me verify whether it's really deployed or not. Yes, I can see that v1 one deployment, v2 another deployment. So there are two deployments, both belong to the same service, which is running on port 5000. How I am going to access it? I can access Minikube sh I can connect to the Minikube host. I can describe my service, describe the name of the service. That can give me where all the application is running. So I can use the curl command. I can say hello is the context path. So I'm getting v2 because I'm directly running the same. Now I'm going to get the other IP and service. Now from my Docker Minikube host, I'm able to test it. Okay, now we need to access this part. We are done with it. According to the deployment, this pod hosting, service hosting, we are good with it. Now we have to host the routing service so that can connect with the gateway service. So first I have created this namespace. In this namespace, I have hosted the service and deployment. Now let's host HTTP route. Now what I'm going to do is I'm going to deploy a route service. Which namespace I wanted to host it in the same. So prior to that, vi, I say HTTP route. So here I'm defining, this is what they were talking about, the beta API version. So this is the API version, gateway networking. To have this facility available, we're supposed to deploy the CRD. Without CRD, we cannot test this. After applying the CRD from the prerequisites, we have to configure the HTTP route with the version beta API. The kind is HTTP route. The name of the route is hello world. Parent reference specification, I'm declaring the name of the gateway is Narayana XLB, external load balancer, where it is being hosting NS gateway, and anything which is coming and matching with this, and forward the request to the backend system with 5000 port and hello world name of the service. That means this one we are going to host it. Now let's go ahead, apply HTTP route. Now whether my route has been deployed or not, we don't know. We need to check that. Get HTTP route. I can see that my routing has been deployed. In case if you want to know more details, yes, describe, and you can see that. Okay, you can deploy, and it is saying that it is status is parents. It's nothing is being showing parent reference. That means we are really depending on the gateway service. Now we have deployed HTTP route service. I'm going to deploy the gateway service. Let's go ahead and open the gateway service. Now what we are doing is we are going to create a gateway service of the beta version, and the name of the gateway is Narayana XLB, where I am deploying in this namespace, and who is the gateway class provider, Ishito. This is the controller which is being used, and listener, I'm going to listen. What is the name of the listen is HTTP, and in case if you want to host name, yes, you can do it. Right now I'm disabling because I wanted to access from the external without host name IP mapping. So then what is the port of the gateway I'm going to run? 80. And what type of protocol? HTTP. Allowed routes from all the namespaces, because I have now two different namespaces. Namespace gateway, namespace hello app. I need now request responses, both the system namespaces. How that is how you need to specify. If it is all deploying in the same namespace, you specify there same. Now let's go ahead and apply that. Which namespace? Gateway. Apply f gateway. Now you can see that my gateway has been created. Get gateway. I can see that full details. The gateway name is this. The gateway class provider is, according to the architecture diagram, the implementation providers here, gateway class is Ishito. Okay, we are writing the scripts from here to here. This one I'm reusing from Ishito open source controller. So you can see that the provider is Ishito. If it is a console, glue edge, likewise you need to deploy those things. And my load balancer is ready to serve my request. That means we have hosted this. Let's go ahead and test my application by connecting from the load balancer. Now I use curl. This is a load balancer. I'm going to use, I say hello. Now I have received, now the request is being made from CURL and it is making call to this load balancer, and it routed the request to hello world, the exact match, that is /hello. Then it is matching to service matching to now v1 you have seen it has been printed. Let me rerun that. Now you see that it is now calling v2. That means v1, so first time request from the same client went to v1, second time the request went to v2. That means your request is being properly load balancing according. Now this I can test it from the CURL. Now I wanted to test this service from outside world. How I'm going to test that? I cannot directly access outside the Kubernetes engine from the Linux host. For that, I supposed to follow a port forwarding mechanism on the service name. So the name of the service is sample XLB Narayana. This is the standard way which is defining. Okay. So what is the namespace? GW. Now you see that this is the namespace where the Ishito Ingress controller is running. This is the service which exposed with 80. So I need to access from outside my box. So now let me go ahead and test it, my application. I'll go here, localhost, I say 8082. You see that now v1 invoked. Let me retest that. Again v1. Now you see that it is v2. Likewise, the request gets dispatched from my browser. So this is my browser client or CURL client. If it is a CURL client, within the box I can test it. From the browser, I test this is my Windows machine is my client, and then request is going to connect to the gateway, that is Narayana XLB, which is running, that makes a route to HTTP route. HTTP route makes to call to the service. Service makes call to two different version of the application pods, V1 and V2, because the load has to be separated between every request. That's the real time, hands-on session. That's the end of the demo. That's the end of the demo. If you have any doubts, please post it in the comments. Thank you for watching. Please like it, share it, comment it, and subscribe it. I'll come up with a new video. Stay tuned. Thank you.